Good afternoon, my dear students. Today I am coming up with a new topic that is called increasing and decreasing function. Very interesting topic. And before going to discuss about the increasing and decreasing function, let us we understand a particular term that is called monotonicity. What actually monotonicity is? You know, in our life, when we see that there is no change, हम लोग कहते हैं कि लाइफ मोनोटोनस हो गया है. ओके, कोई चेंज नहीं है, जैसे था ऐसे रह गया है. So this particular concept is going to use in terms of the function. You see, I am going to draw a graph. To graph, you see from the graph you can understand what actually monotonicity is, or monotonic. This is a function, and again another function. From the function you observe that here the function is what? Increasing. That means it is increasing, there is no change throughout its domain. There is no change throughout its domain. ये increasing पहले थे और last तक क्या रहा? वो increasing भी रहा. Here the function is what? Decreasing. So y equal to fx is a function. You will consider, and this function is what? Decreasing throughout its domain. That means what happened? जैसे था ऐसे रह गया. That is called it is monotonic. This is called the function. Both the functions are called monotonic. So here monotonic is this particular function is called monotonic increasing, and this is called what? Monotonic decreasing. So monotonic means what? No change. जैसे था ऐसे रह गया. And if I consider another graph, suppose this is the graph. Okay, this is the graph of a function, and from this graph you see. There is a, suppose from here to here, this is the domain of the function, and throughout the domain what happens? Sometimes function is what? Increasing, and it get a saturated point, again decreasing, again increasing. So such type of function are not called monotonic. It is not called monotonic. But if you divide the interval from this interval to this from this, in this interval what happens? The function is increasing. So it is monotonic in this interval. Okay, monotonic increasing, and from here to here this function is what? Decreasing. From this to this there is another interval, and in this interval function is what? Monotonic decreasing, and again from here to here the function is what? Again increasing. So it is called monotonic increasing. Okay, but throughout the domain it is not monotonic there, because there is a change. You consider your life, जैसे हमारा लाइफ के बारे में सोचेंगे तो उस तरफ का लाइफ कैसा हो रहा है? ऐसा चेंज होता रहा है. सो दिस इज नॉट कॉल्ड मोनोटोनिक. एंड इफ देयर इज नो चेंज, जैसे लाइफ चलता रहा था पहले से और लास्ट तक सेम रहा, सो इट इज कॉल्ड लाइफ इज मोनोटोनस. ओके, सो हियर दिस इज देयर इज ए चेंज विथ रेस्पेक्ट टू what is the function. From the graph you will see there is a change in different time, but in a particular interval there is no change. In this interval it is increasing, in this interval it is decreasing, in this interval it is what? Again increasing. So throughout the domain it is not monotonic, but in a small interval it is what? Monotonic increasing or monotonic decreasing. And here in throughout the domain, if you consider the domain of the function this in this called x-axis, then what happens? Throughout this domain the function is decreasing, throughout this domain function is increasing. So it is monotonic increasing, it is monotonic decreasing. Okay, now we understand, now we are going to apply, and there is a mathematical concept that how the function becomes increasing, and then we are going to apply the application of derivatives to know when a function is increasing, when a function is decreasing. Very interesting topic. Now comes to this graph. This is x-axis and this is what? Y-axis. Okay, suppose that I take two input, one is x1, another is what? x2, and corresponding output is this one. Okay, corresponding output is this one. Here obviously x2 is what? X2 is what? Greater than what? X1. Yes, this input is greater than that input. That input, and corresponding output, this is what for x1, if y is equal to fx is a function. Okay, then this point consider on y-axis is fx1. This is the output. Fx1 is the output of the input x1. Okay, similarly this is x2. The output is what? fx2. Okay, so x2 is greater than x1. From the graph it is clear that fx2 is greater than what? fx1. Okay, so if you take any two input on the domain, in any two input in the domain, then corresponding output will maintain the same sign, here greater than, here also greater than. Okay, so in such cases you can say that the function is what? Increasing function. Function is what? Increasing function. Here x1, you can say x1 is less than x2, implies fx1 is less than what? fx2. So here the sign is less than, here sign less than. So both the statement are what? Same. Okay. So in such cases the function is called what? Function is called what? Increasing function. Rather you can say strictly increasing. Strictly increasing. Okay. It is strictly increasing. And if you come across this particular graph, you see if you give two input, suppose this is x1 in the, this is 2 point x1 and x2. Corresponding output, this is the output of for x1, this is the output for what? x2. And if you, this is your fx1, okay? This is your fx1, this is y-axis, and this is what x-axis. And for corresponding x2, what is the output? Corresponding output is what? This one, fx2, this one, and fx1 is this one, okay? So from the graph it is clear that x1 is less than x2. x2 is greater than x1, implies fx1 is greater than what? fx2. So it is very simple. You see that is x1 is less than x2, implies the input x2 into the input x2 is greater than x1, but corresponding outputs there is a reverse sign. There is a reverse sign. What happened? तो x1 x2 से छोटा है लेकिन fx1 क्या हो गया? fx2 से बड़ा हो गया है. Okay, so in such cases the function is called what? Decreasing function, or rather you can say it is a strictly decreasing function. It is a strictly decreasing. This is a simple definition to understand mathematically when the function is increasing and when the function is decreasing. Now our objective is application of derivatives. How to use derivative to know the function is monotonically increasing and function is monotonically decreasing. So let us use this concept. See, again I am going to draw the graph. This is a graph of function. Okay. This is called what? Already we tell that this is a increasing function, or you can say it is a strictly increasing function. If you take any point, this is the point or this is the point, whatever be the point, and if you draw a tangent in this point, this I am drawing a tangent, and this tangent makes an angle, suppose theta, make an angle theta with the positive direction of x-axis, then tan theta is the slope of the line, right? Tan theta is slope of the line, slope of the tangent, this particular line. But since it is a tangent at this point, suppose this is the point P, and since this is the tangent at the point P, and therefore we can say that slope of the tangent is dy by dx by according to calculus. So both are the slope, so both are same. Since this is an acute angle, this is an acute angle, you know, acute angle lies within first quadrant. Acute angle lies in first quadrant, and in first quadrant tan theta is what? Positive. So this quantity is positive. That means what? Dy by dx is greater than 0. Dy by dx greater than 0 means what? F dash x greater than 0. Okay, f dash x greater than 0. That means if a function is monotonically increasing, what is the condition? F dash x greater than 0. If you know, if you find f dash x and if you show that f dash x is greater than 0 in a particular interval or particular domain, then you can say that the function is monotonically increasing throughout this domain or in a particular interval. Okay, so now we are going to apply calculus here. If you find f dash x and if we show that f dash x is greater than 0 throughout this domain, what domain, or in the particular f dash x is greater than 0 in a particular interval, in a particular part of a domain. then you can say that that is fx is increasing throughout the domain or in the particular part, whatever you get. Okay. Or you can consider another point here. You see again making acute angles. So this is an strictly increasing function. And when strictly increasing, then only greater than 0 sign will introduce it. F dash x is greater than 0 means fx is strictly increasing. Fx is what? Strictly increasing function. Let us I am giving another example. Another example. Here you see. Suppose there is a function. Okay. Okay. This is the function. And here you see in this point you can draw tangents, and tangents are what? Making angle, acute angle with the positive direction of x-axis. Inclination is what? Acute, and therefore f dash x is greater than 0. Here, all the points. You can consider this point, this point. Everywhere tangents are making acute angle, and therefore f dash x is what? Greater than 0. But here you see, if you draw a tangent, the tangent, this is the tangent. All the points from here to here. Okay. From to here, this is suppose there are few points on the domain. Few points on the domain where what? F dash x tangent are parallel to x-axis, means f dash x equal to 0. So combining these two, we can write f dash x is greater than equal than 0 for all x belongs to the domain of the function. For all x belongs to the domain of the function. In such cases, you cannot say the function is strictly increasing. You have to say only increasing. So this is an example of an increasing function, not strictly increasing. And when you get f dash x is strictly greater than 0 for all x belongs to the particular domain, then you can say that it is what? Strictly increasing function. Okay. I hope you understand. Now going for a decreasing function. Two graphs. First graph is this one, suppose. This is the graph. Another graph is, suppose, this is the graph. Okay. From this graph you see, if you draw tangents, then you see tangents are making an angle this. This is the inclination made by the tangent. Inclination means what? The angle made by the particular line with the positive direction of x-axis. And this is suppose theta. And slope of the tangent is tan theta. And according to calculus, slope of the tangent is what? F dash x. And since theta is an obtuse angle, here it is obtuse angle, okay? Obtuse angle lying between what? 90 degree and 180 degree. That means it lies in second quadrant. And in second quadrant, tan theta is what? Negative. So f dash x is what? Less than 0. So the function is strictly decreasing. The function is strictly decreasing if f dash x is equal to 1, 0. This is the condition that a function, if you show that f dash x is less than 0 throughout its domain, then you can say that the function is strictly decreasing. Okay. And if you show that f dash x is less than 0 in a part of a domain, then in the part of the domain function is strictly decreasing. And in this particular function, again you see, these are the tangent makes angle what? These are angle over. These are the angles obtuse, okay? And finally, tan theta is negative. That means f dash x is less than 0. But in these points, the tangent is what? Parallel to what? Tangent is what? Parallel to what? X-axis. And here f dash x is equal to what? 0. Or in this area, or from here to here in the domain, what happened? From here to here in the domain, f dash x is less than 0, f dash x is less than 0, and in this particular point in the domain, f dash x is equal to 0. So combining these two, you get f dash x is less than equal to 0. Okay, for all x belongs to the domain of function, and then you can say that fx is what? A decreasing function only. Or you can say not use the word strict. We just use it is a decreasing. It is a what? Decreasing function. And when f dash x only satisfying the condition less than 0, strictly less than 0 throughout the domain, then from here we can say that the function is what? Function is what? Strictly decreasing. Function is what? Strictly decreasing. So we understand that when function is increasing, a function is increasing throughout its domain if f dash x greater than equal than 0 for all x belongs to the domain. Okay. So increasing के लिए क्या condition है? Finally, what is our conclusion? Our conclusion, the function f increasing means f dash x greater than equal to 0 for all x. I am considering the domain for all x belongs to the domain, and f is strictly decreasing implies f dash x is strictly greater than 0 for all x belongs to the domain of the function, and if f is decreasing means f dash x is less than equal than 0 for all x belongs to the domain of the function, and if f is strictly decreasing, then what? F dash x is strictly less than 0 for all x belongs to the domain of the function. Okay, this is the basic idea about the increasing and decreasing function. How to apply calculus to know a function is strictly decreasing or just decreasing, or strictly increasing or just increasing. This is the concept behind that. Okay, I am going to solve a simple problem. In next class I will solve more problems related to this topic and get overall idea. You get the how to show that a function is increasing or decreasing, how to find the intervals where the function is increasing or decreasing. Okay, so one problem I will solve today. One or two problem. The question is, show that the function f(x) equal to, question is x cube minus 3x square plus 4x. This is a polynomial function, so its domain is what? Set of real numbers. Show that the function f(x) equal to this is increasing throughout its domain. So to know how a function is increasing, you must know about the f dash x. So find f dash x. If you derive this function x cube, derivative of x cube is equal to what? 3x square. Derivative of 3x square is equal to what? 6x plus 4. Little arrangement is required. 3x square minus 6x plus 3 plus 1. I am writing like that. And if you take 3 common, you get x square minus 2x plus 1 plus 1. We can write this. These are the simple calculation. And this can be written as 3 into x minus 1 whole square plus 1. Okay. Now, very interesting. See. Here you see x belongs to R, right? X belongs to what? R. So x minus 1 also belongs to R. We know that difference between two real number is again a real number. Okay. Since this is a real number, we know that if you square a real number, it cannot be negative. It is a non-negative quantity. So x minus 1 whole square करने से क्या होगा? It is always greater than equal to 0. It may be 0. When it is 0? Because when x is equal to 1, it is 0. Otherwise, you put any real values of x, it is always positive. So x minus 1 whole square is greater than 0. If you multiply to 3, you will get being greater than equal to 0. And now our expression is this one. So if you add 1 on both sides, this is greater than 1, and 1 is strictly greater than 1 is what? Strictly greater than 1. So this is actually what? It is what? F dash x. So f dash x greater than 0. Okay? For all x belongs to R. For all x belongs to R. That means what happened? In throughout this domain, f dash x is strictly determinate. Then when you can say that fx is strictly increasing, or rather increasing, an increasing function, and a strictly increasing function is also called increasing. But an increasing function may not be strictly increasing. Okay. So since it is an strictly increasing, so automatically we can say that it is increasing. Okay. So from here you write, this is greater than 0 for all x belongs to R. Why greater than belongs to R? Because of this. You have to write in the right part of the problems. Okay. So therefore you can say that fx is strictly increasing throughout its domain. Throughout its domain. So this way you can solve the problem, apply the first order derivative to understand when a function is increasing or not. This is a very simple question. So another question I am going to solve, then more clarity will come. The question is, prove that the function fx equal to cos x, number A, strictly increasing in 0 pi. This is the first question. In 0 pi, next question I am going to write. So you have to show that within the interval 0 to pi, fx is equal to what? Cos x is strictly increasing. You go to the graph of cos x. It's very interesting. This is what pi by 2. This is what pi. Then go on. And at when x is equal to 0, the cos 0 equal to what? 1. So graph will be start like that. Okay. Similar this minus pi by 2. Graph will be like that. Okay. Now here you see from 0 to pi by 2. From 0 to pi, in this interval you see function is what? Strictly increasing. I'm sorry here. See another way. Okay. The given function is what? Fx is equal to what? Cos x. Okay. So find f dash x. F dash x is equal to what? Minus sin x. F dash x is equal to what? Minus sin x. Now within the interval 0 to pi, if you use the quadrant rule, this is 0 to pi. Consider in sin x. You see sin x is positive in the first quadrant as well as second quadrant. So we know that sin x is greater than 0 for all x belongs to what? 0 to pi. 0 to pi. So minus sin x is less than 0 for all x belongs to what? 0 to pi. So my question is strictly decreasing. Something wrong here. So this question you write, replace strictly decreasing in 0 pi. So this is less than 0 for all x belongs to what? 0 pi. So within this interval what happened? F dash x is strictly less than 0, and when f dash x is strictly less than 0, we can say that fx is strictly decreasing. Therefore fx is strictly decreasing in 0 pi. This is the first question. The next question B. Continue the question. Strictly increasing. F is strictly increasing in pi to pi. You have to show that fx is strictly increasing in pi to pi. Again use the quadrant rule. Very interesting. If you see pi to pi, pi means what? Up to this level 0 to pi, this is pi, and pi to pi means what? This quadrant and this quadrant. Interval pi to pi means what? This third quadrant and fourth quadrant. And we know that in third quadrant and fourth quadrant, sin x is what? Negative. This is your sin for finding the f dash x. So sin x is what? Less than 0 for all x belongs to what? Pi to pi. Okay. So if you multiply the minus, तो माइनस से मल्टीप्लाई करेंगे तो साइन क्या हो जाएगा? चेंज हो जाएगी. तो माइनस साइन x is nothing but your what? F dash x. That means what? F dash x is cathode. So solution. So f dash x क्या था? Minus sin x, and which is greater than 0 for all x belongs to pi to pi. I hope you understand why it is greater than 0, because of the quadrant rule. And finally you can say fx is strictly increasing in the interval pi to pi. In the interval what? Pi to pi. I hope you understand. And this way we can find the function is increasing or decreasing, where it is strictly increasing, where it is strictly decreasing. So another very nice question, that is what? The question is, suppose fx is equal to what? Cos x is the function. The question is that the fx is equal to cos x is neither increasing nor decreasing in 0 to 2 pi. In 0 to 2 pi. It is neither increasing nor decreasing. Clear? When a function is neither increasing nor decreasing, suppose I have given an example in the graph. Suppose this is the domain of a function, and if the graph is like that, suppose this is the graph. Okay. So here within the throughout this domain, sometimes function is what? Increasing, and sometimes function is what? Decreasing. In such cases, we can say that this particular function f is neither increasing nor decreasing in the particular interval r. अगर ये डोमेन है तो I के अंदर फंक्शन क्या होगा? Neither increasing nor decreasing, because it plays sometimes as a increasing, sometimes what? Decreasing. You cannot say it is an increasing function, or you cannot say it is a decreasing function. Rather you can say it is neither increasing nor decreasing function. But if you divide the whole interval into some part, okay, then again you say this is increasing here, from here to here, from here to here it is decreasing, from here to here it is increasing, and from here to here it is again decreasing. But throughout this domain is neither increasing nor decreasing. Okay, so this is the question is demanded, that fx is equal to cos x is neither, show that, question is that, show that fx is equal to cos x is neither increasing nor decreasing in the interval this interval, okay, in this interval 0 to 2 pi. So again you find f dash x equal to what? Minus sin x, and 0 to 2 pi is divided, this is your interval 0 to 2 pi, okay, 0 to 2 pi. This divided into two interval, one is 0 to pi, one interval 0 to pi, another interval pi to 2 pi. We already saw that within the interval 0 to 2 pi, 0 to pi, the function is what? Strictly decreasing, and from pi to 2 pi it is what? Strictly increasing. So you can write, since f dash x is less than 0 for all x belongs to what? 0 to pi, and f dash x is greater than 0 for all x belongs to pi to pi. Therefore fx is strictly increasing, strictly decreasing in 0 to pi and fx is strictly, you write increasing, strictly increasing in pi to pi. So whole interval में इस part में क्या है, it is decreasing, इस part में क्या है, it is what, increasing. So throughout this whole interval what I mean, it is neither increasing. Therefore we can conclude that f is neither increasing nor decreasing in this interval 0 to pi. Therefore you can say f is neither increasing nor decreasing in the in pi and 0 to 2 pi, in 0 to 2 pi. This is the answer. So another very interesting question I am going to discuss now. Another very interesting question. The question is that, suppose that your question fx equal to what, x square, where x belongs to r. Whether this function is increasing or decreasing in throughout this domain R. Domain is what, set of real number. If you find f dash x, it will be twice x. And twice x is a number which is greater than 0 when x greater than 0 and less than 0 when x less than 0. अगर positive, this is your domain, na? Domain set of real number minus infinity to plus infinity. This is your 0. Okay? And when all x, positive mean for positive x, when x greater than 0 and when x less than 0. When x greater than 0 what happen? When x greater than 0 what happen? Twice x is also greater than 0. That means f dash x is greater than 0. That means from minus 0, from 0 to infinity. That means in this interval what happen? The function is what? Increasing. The function is what? Strictly increasing. Or from in this interval minus infinity to 0. When x less than 0, f dash x is also less than 0. And you can conclude that in this interval what happen? The function is what? Decreasing. So we can conclude that the function is neither increasing nor decreasing. So question asks, is the function is increasing? The question is that is fx equal to x square is increasing. What is your answer? Your answer is it is neither increasing nor decreasing, because throughout this domain in some subinterval it is increasing and in some subinterval it is decreasing, and hence you can conclude that it is neither increasing nor decreasing. So I hope you understand. Okay. So thank you very much to attend my class and go through the video class 2-3 times to understand the idea behind the concept of increasing and decreasing function, when it is strictly increasing, when it is strictly decreasing, when just increasing, and when just decreasing, and what is actually monotonicity. Actually monotonicity means there is no change. जैसे जिंदगी थे ऐसे रह गए, जैसा रियल लाइफ में अगर आप सोचेंगे तो फंक्शन क्या है, जैसे था ऐसा रह गया, कोई चेंज नहीं हुआ, तो उसको आप कहेंगे मोनोटोनिक. तो जो इंक्रीजिंग फंक्शन होगा, स्ट्रिक्टली इंक्रीजिंग फंक्शन, उसको मोनोटोनिक इंक्रीजिंग कह सकते हैं, और जो स्ट्रिक्टली डिक्रीजिंग होगा उसको क्या, मोनोटोनिक डिक्रीजिंग कहेंगे. सो आई होप यू अंडरस्टैंड. Go through this text again, you try to understand all the basic concept behind this. When your base is clear, then you can solve big problems. Thank you very much. Thank you.